Okay, hello, welcome to Micro. Now we have lab task for program number 1, which is Peace, Love, and Code. We will create and design a display showing the graphics found at the cover page of this experiment handouts. The first thing we need to do is draw the schematic using Tinkercad or Fritzing's software. Alright, for the example here, for our code, for the sketch of program number 1, we will having a library of wire.h and liquid crystal of I2C.h. For the liquid crystal, we will set the LCD address to 0 by 27 for a 16 by 2 LCD. This byte represented the piece first that we will be displaying it later, piece second, piece third, heart first, heart second, code first, and code second. These are the following representation of the visual that will be presented in the LCD. First of all, in the void setup, we will need to initialize the LCD and turn on the backlight for us to display the following characters. And each of the characters representing of the function of LCD create character, and this one sets the cursor position and display of custom characters of each peace, love, and code. And that's it. Simple as that. Now we will try to simulate if it is working. Okay, now as you can see here, it's displaying peace, love, and code here. Now for the pinouts of analog A4, analog A5 for SDA and SCL, and VCC as usual for 5 volts and the ground. Okay, that's it for program number 1.
Now for Laboratory 7, Program 2, entitled Interfacing Liquid Crystal Display or LCD with Arduino Uno board, we are tasked to create a marquee message, which is to create a design a message marquee system. The program will be controlled by two light-dependent resistors or LDRs in displaying the two marquee message. That is, if the left LDR has sense, it will display the marqueeing message from left to right direction, saying welcome to the PUP CPE department. Otherwise, it will display the marqueeing message, goodbye, see you again next time, from left to right direction. So as you can see here, we have here, let's first review what are the components that we have here. So we have Arduino Uno 3 photoresistor, 220 ohms resistor, and one PCF8574 base. And as you can see here, the I2C. So now let's try to simulate this one. So let's see. Welcome to CUP CPE. Right there. Then if we put it like that, this one for this resistor, you can see here, next time you again. It's see you again next time. I think we did the objective. So now I'm going to explain the codes to you. So let's stop the simulation. Then let's go to the code. So we have used this include. So as you can see here on our code, this code utilizes wire and liquid crystal underscore I2C libraries to interface with liquid crystal display or the LCD over I2C and to read values from photoresistor to display different messages based on light levels. So this WAR.H allows communication over I2C, while the liquid crystal underscore I2C enables control of LCD display using I2C communication. For initializing LCD, we have here the 0x27 I2C address of the LCD. The 16 is the number of columns and the 2 is the number of rows. So for declaring constant and variables, we have here PHTR1 equals to AO. As you can see here in the comment, it is the analog pin for the photoresistor 1 for welcome. The next one is the analog pin for the photoresistor for goodbye. Next, you have initialized threshold to 20. So the threshold value for light detection, the light level threshold for detecting the presence or the absence of light, and then the show message 1 and show message 2, it flags to determine which messages to display. And here, it's either the welcome or the goodbye. For the set of function, we have, of course, serial.begin 9600 to initialize serial communication for debugging purposes, and then the LCD.init or the LCD backlight, LCD print, LCD.clear is a setup and to initialize the LCD. For the void loop function, we have used analog read PHDR1 and the read analog read PHDR2. This is to read analog values from the photoresistors that we have here. And then the serial dot print, of course, it prints the values to the serial monitor for debugging. Then the show message 1 and show message 2 determine if the respective messages should be displayed based on light levels. Photoresistor 1, photoresistor 2. Now we have here the LCD.clear here. LCD.clear it is to clear the display, and the display marquee is to call the function to display messages with scrolling effect. As you can see, based on the instruction, we have to create left to right and then right to left. For display marquee function here, for display marquee function, the length, of course, it signifies the length of the message. The display length is the length of the LCD row loop through the messages to create a scrolling effect by updating the display position. The LCD.set cursor, this one, LCD.cursor, it sets the cursor to start of the first row. The LCD.print, print the part of the messages on the LCD. As you can see here, the comment says print substring starting from the position. And of course, lastly, the delay 300, which adjusts the delay for speeding for the speed of scrolling. So this code set ups an Arduino to read light levels from two photoresistors and display different scrolling messages on an LCD base. On a light detected, the display marquee function handles the scrolling effect for the messages. So that's it for Laboratory 7 Program 2. For Laboratory 7 Program 3, we have created a basic functional calculator. So this code right here is written for an Arduino microcontroller to create a simple calculator using the keypad LCD display. It also incorporates a buzzer for auditory. For library and inclusions and definitions, of course, this will never not be here. So this allows interfacing for I2C LCD screen, and the keypad.h provides the function to interact with the matrix keypad. We also have here our constant, which is the definition, uh, the constant and variables of our keypad, which defines the number of rows and number of columns, and the character keys, rows and columns. These two, the array defining the characters on the keypad buttons. The byte row pins rows, right here, basically, as well as the columns. So these arrays specify the Arduino pins connected to the keypad rows and keypad columns. So keypad my keypad, it creates a object name my keypad using the key map and pin configuration. So again, like the previous code, we have liquid crystal underscore I2C LCD. So it basically creates an LCD object named LCD with I2C address UX27 and dimension of 20 columns by 20 rows. For more constant and variables, we have, of course, to initialize the buzzer pin, it basically sets the pin uh, that is connected to the pin 12. Uh, the buzzer and the pin 12 is basically connected, and the Boolean present value and Boolean final value, it flags to track the state of number entry and calculation completion. So the string number one and number two, it strings to store the input numbers, while the initialized result and float result, it is these are the variables to store the result of each calculations that will be made. We also have here this one, which it is a variable to store the operator. For our setup function, we use the void setup, of course, our setup function, which initializes the setup. We use again the pin mode buzzer like we used to our use activities. So it sets the buzzer pin as an output. We have LCD dot in it, and then the backlight, which initializes the LCD and turn on its backlight. This one. We have here startup messages. Once you open and simulate the calculator, you can see here Dell, Micro, and calculator. We also have here our startup tune and startup melody, of course. So it corresponds to different tunes and different melodies, and these are the duration of such. So for our for loop, this one, our core block of codes. So this is the startup melody on our buzzer, which has a delay of 2 seconds. We also have here again the LCD dot clear, which are the subsequent lines, basically clears the LCD and prompt the user to enter a number. For our main loop function, we have this one, our main loop function. We have here a function that basically runs continuously. We have here character key my keypad get key. So it basically reads the pressed key from the keypad. So we have here our if block right here. So it basically handles digit input and updating the display. So we have this one. It play button press sound. So it plays a tone on a buzzer to indicate basically that the key is pressed. So for our this one, our another if block, we have numbers right here, which is updated based on the present value that we have. Next is the else if block, which handles the operator. So basically, this has tone 12 1050. Again, it plays a tone on a buzzer for operator input, and then the OPS set for present value, which is set to true. The next else if block handles the calculation when the equal sign is pressed. Based on OP, the appropriate calculation is performed. This one. Again, plus. And then the result is displayed on the LCD. After displaying the result, the system resets for the next calculation. You have here again the clear and then your answer. And then you basically have to enter again your number. And lastly, for our last else if block, right here, it handles the C. This one. The C is basically for clearing all the input. So the subsequent lines are for clearing the input. So the input fields and the result are gonna be reset. Basically, this code provides a simple but functional calculator, handling basic operation, displaying results on the LCD, as it includes auditory feedback using a buzzer to enhance the user interface. That's all for Laboratory 7, Program Number 2.
For program number 4, this is a password-driven piezo buzzer. We will design an Arduino circuit for a password-driven running LEDs. The program will ask the user to enter a password through the keypad. If the password is incorrect, it will buzz with the correct musical tone of choice and a running LED light from left towards right. Otherwise, it will be display the incorrect running LED pattern of our choice together with the sound of password. And ask again the user to enter the correct password. Provide 3 tiles or the correct password. At the last time, if the password is still incorrect, Arduino will display the keypad will now accept it. It should display the corresponding prompts such as entering name, okay, etc. Okay, since this program number 4 is already we already did it in the past laboratories, but this time we will be having an LEDs here. Let's see. The LCD here. We will be having an LCD here for program number 4, but we still used it last time. So I will explain it again. This time we will be including 2 libraries for the LCD, which is keypad.h, liquid crystal underscore I2C.h. As usual, we'll be initializing the keypad setup of 4x4 columns and the arrays of rows and columns. For the byte row pins of the pin assignment and keypad here, how to represent the keypads. This is the LCD setup of A2. It will be setting the LCD address to 0 by 27 for 16 characters and 2-line display. Constant integer of variable here, and constant integer of password pen assigned to number 10. And password and user setup will be LC207. Okay, this must be our password. Okay, for interboolean through enter password is false. Boolean access granted is also false. Integer attempts here must be 0 and constant integer of max attempt up to 3. We will be having an unsigned long for lockout time if equals to 30 seconds of lockout time, and unsigned long of lockout starting at 0. And having a boolean variable here is locked out equals to false initially. For the void setup that will be running singular for the single time, we'll be having a for loop of assigning a pin mode of LED pins and the initialization of our LCD, which will be printing press hashtag to enter and set cursor, your name, LCD clear cursor, and lastly printing of entering the name. For the void or running lights function here, we'll be having an integer start until the end, and we'll be repeating for the LED representation if it will be high, and if else it will be turning on the low. Having a function also here for success patterns, we'll be having a piezo buzzer that will be playing our specific zone here, having a delay, and this function is for loop here is to turn on the LED from left to right. Okay, as you can see here, it's pretty much self-explanatory of digital for loop here of digital right of LED pins I plus 1 high will turn on the LED lights and turn off LEDs if too low, and lastly of a delay of 1.5 seconds of digital light of LED pins if lastly to turn off the lighting LED green LEDs from the above. Having also a function of field pattern from running lights, which is to run the running lights from analog 0 to analog 5 pin 3 times. Having a for loop function here of digital right LED pins ito high, which is turning on the red lights and also turning on the green lights. And lastly, after a delay of 0.3 milliseconds, we will be having a delay of the 3 seconds of 0.3 second of delay. And lastly here, if it is corresponding the field pattern, we will be playing a specific tone differently from the success one, and also the corresponding light effects that matches our music. Lastly, our void loop that will be running continuously. This is our main function. If it is locked out, we will be also displaying on the LCD that from the start that will be prompting enter the password. Lastly, if returning, do nothing if it is lockout period. Character key of initializing my keypad to get the input from the user. If key and if else statement of here. If enter name face, and if else statement of adding a plus. If username of length is greater than 0, it will enter name face to false and enter password face into true. If it is finished entering the name face, and we'll be also displaying that there's hashtag to enter and of printing password into prompting the user that he needs to print the password. Having an else statement getting out of the if else of the key here. This time will be if enter name face, it will be okay, I'm sorry, that if the user here close, okay, it's here. Okay, so if the key pressed of plus, else the username will be move to the second line of the LCD and print the username so far, And lastly, of else next is else if of enter password phase. If key equals to number sign, if input is true to the password, it will be access granted, and also the success pattern which corresponds to the LCD that access is granted, welcome, and will print the username plus the exclamation mark. If else, if we are wasting the attempts of inputting the wrong password here, will be access denied, try again later. And else, if it is the wrong password again, we will have attempts of printing the number of attempts, and wrong password is clearing the input and delay of 1 second. If it is locked out, clear the cursor and enter password. Else, if clear input of hashtag is pressed, we will not exhaust any attempts, but only clearing the LCD of any input. And lastly, if the input append the press to the input, if we move to the second line of the LCD, print the input so far. Alright, so now let's check if it is working as intended. So let's start. our string password is LC207. Okay, let's do it. Start the simulation. Okay. Oops. Say I'm E65C. Alright, please enter the password. 3, 2, 1, 1. Oops, I'm sorry. 1. C. Let's try to input the correct one first. 2, 0, 7. Enter. It is correct. This is granted. E65C. Alright, how about we will be starting the simulation, and we will be having the wrong attempts until we get locked up. Okay, I am 007. 007. Okay, press. Say 1, 2, 3. Oh. Okay. How about let's try 258 and clear. Okay, it is working. We will not exhausting any attempts. How about wrong attempts this time again? Oh no, it is wrong. Okay, lastly, our last attempt. How about ABC? Okay. Okay, access denied. Try again later. Alright. That's it for our program number 4.
For Laboratory 7, Program 5, we have here our simple video game called Obstacle Fever. So it is running on an Arduino with a keypad and an LCD screen. The player moves a character on the LCD to avoid obstacles that move from right to left. So let's start the simulation for better visualization of it. So I press any button for it to start. As you can see, if I press pause, the game is paused. Then if I press reset, it resets the game. Let's try. So you can see it starts playing. So you basically just have to avoid of all the obstacles by pressing buttons. Up, up, up. Yeah. It goes up and then when you press down and once you hit the obstacle, it will display a game over. For better understanding, let's review our code. So you can see here we have here comments in order for us to properly understand the code. So of course, we have to set up our libraries and global variables. So the key dot h is to handle input from 4x4 matrix keypad, which we used. The var dot h is for I2C communication used by our LCD, and the liquid crystal that I2C dot h is to control the LCD via I2C. So of course, you have to initialize the LCD and the dimensions of 16 columns and 2 rows. Let's move on to our game setup, which is right here. So as you can see here, we have columns and rows, of course, again for the dimension, and we have player X and player Y. It defines the player position. Basically, uh, it sees where's the position of the player on the LCD. And then we have here the number obstacle, which is summed up the number of obstacles that we're going to encounter throughout the game. And of course, our obstacle underscore X underscore Y and then underscore F, which is an arrays to store the position and the state of the obstacle. Next is the keypad setup. Um, this is the key mapping for the keypad, the pin connection for the keypad, the keypad, this one, the keypad, it is used object to read input from the keypad, this one, keypad. So as you can see here, we have 4 rows and 4 columns corresponding to this one, 4 rows and 4 columns. So next here is the game timing variables. So, the game timing variables basically is the variables to control the game timing and intervals, the score, game over, and pause to track the game state. So you can see here's score, it initializes the score, and then the pause, it tracks if the game is in pause state. We use the piezo buzzer because of course the video game has to have a sound. So the pin for the buzzer and the music note definition is right here. From the past laboratory, we also define different keynotes. If we use the piezo buzzer, we have different activities that you can check our YouTube channel for another example of where we use the notes. For the setup function, we use to initialize the LCD and the buzzer. So it basically initializes the LCD and buzzer, this seed random number generator, and display the initial game messages and wait for a key press to start. Because here, I think we have used this before, but in different scenario. Is here random seed analog and then display initial messages. It prints obstacle beaver, then press any button. As we saw from the very beginning, once we start the simulation. Then we have here the setup function. No, that's the setup function, I mean. And we're gonna move on to our loop function. So the main game loop basically checks if the game is over and handles game over logic, handles players' input and pauses the game if necessary. It also advances the game by moving obstacle and updating the scores and display. As you can see right there. Continues normal game logic if the game is not over. We use this for that, and then the interval cost, the interval would be that. So it increases the speed gradually a little bit. Next is the move obstacle. So this one, the move obstacle. As you can see here, the move uh obstacles move and checks basically all the obstacle. So it moves active obstacle to the left and checks for collision with the player and deactivates the obstacle that moves off screen or collided with the player. We have here our simple set of codes. We move left and then initiate game over for game over if it's true. And then this one, the activate obstacle if it moves off the screen and reaches player's position. So basically, if true, it initiates the game over. It continues with this. Next is the spawn obstacle. So spawn new obstacle basically activates an inactive obstacle slot with a random length and position, as well as it sets the position for each part of the new obstacle. Next one is the void update LCD. We have here clear LCD, the LCD that clear, and then display player LCD that set cursor, the player X and the player Y, where their possession. It handles basically all the positioning of the players, the obstacle in the LCD display. Next is the handle input player. So this one reads the keypad for player's movement or game control. It moves the player or toggles the game's paused state based on input. Here checks for keypad for player movement, character keypad dot get key, and then we have here we press 5 to move player up, and then it plays certain tone. If it presses it, move the player down and plays another tone with another note, and then 7, move the player left, 9, move the player right. Every time you move, there are certain note. For example, this one, note C4, as well as this one, this one, this one. Every other note placed in the piezo buzzer are defined a while. Next is the game over. So it basically displays a game over message and the player score, as well as resets the game for a new start. Game over. You press your score. Your score will be shown for that. And then for reset the game, we have here uh the reset game variables. So it basically displays the restart message and waits for a key to be pressed. It also resets player position and deactivates all obstacles. As the keyword imply, it basically resets in the game. I have shown you a while ago in a simulation where I pressed the reset button. and it clearly went back to the obstacle fever press any button. Next for the pause game, um of course it delivers pause messages like how it delivers in the reset game. For the reset game we have reset messages. For the pause button, of course, we have here game paused and then the current score that you are in. So we have here delay interval, small delay to avoid rapid toggling, like what we did a while ago. Next of is the play music. It basically play a generic arcade theme music. As a while ago we defined different notes. Um, those are the notes that plays in the buzzer you via the buzzer, the piezo buzzer, while we play the game. And then whenever you press 5, 8, 7, 9 and the asterisk and the hashtag, we have certain notes with which is the note C4. And lastly, for the play music and play game over music, so these are the music function. It plays, yeah, a simple melody during the game and a different one when the game is over. As you can see, it all varies to the notes. So again, it plays a generic arcade theme music. So the LCD display during the game, it displays the player position, which is the asterisk, and the obstacle, which is the hashtag. So there are messages that will appear in the LCD display, which are the obstacle fever, press any button, game pause or game over, and the score. So for our buzzer, the buzzer plays tone when the player moves and melodies during idle and game over states. Basically, the gameplay, the player moves up, down, left, or right based on our keypad input, and the score increases as time progresses. The game can be paused or restarted using the keypad. This code provides a complete simple game environment on an Arduino using the keypad for input and an LCD for display and a buzzer for audio feed. That's all for Laboratory 7 program.